welcome to Identifying and Defining Oxidation and Reduction. So we talked already about assigning oxidation states. Today we're going to talk about how we can use those oxidation states to identify if a reaction is an oxidation or a reduction reaction. Oxidation reduction is an exchange of electrons. Specifically, one species is going to lose electrons while another one gains them. Oxidation reduction happens all over the place. It happens inside of your body. So a lot of biological happenings inside of you, including things like metabolism, are actually redox reactions. It happens in the production of energy, photosynthesis, etc. It also happens in batteries. It's actually the science behind how batteries work, as well as things like the processing of metals. So metallurgy, taking an ore that you find in the ground and actually turning it into useful materials. Off this branch of chemistry is called electrochemistry, or the other word that we use a lot is redox. So those are some kind of interchangeable terms that you will hear. In class, we're going to be doing a demo where we take a copper wire and place it in some silver nitrate. The following reaction will occur. I'm going to go through and assign some oxidation states kind of quickly here. Silver's always +1, oxygen's -2. By the rules that we talked about the other day, nitrogen here we can solve to be +5. Our copper's all by itself, so its oxidation state is 0. In copper nitrate, our copper has a +2 charge. Our oxygen's -2, our nitrogen's +5, and silver has a charge of 0 because it is kind of on its own. It has an oxidation state of 0 because its protons and electrons are equal. And if we look at this reaction, you'll remember from earlier in the year we have a single element on each side. This is what's called a single replacement reaction. So now what we're going to do is we're actually going to look at electrons a little bit more individually. So I'm just bringing over the charges that we talked about on the other slide. So what we can actually do here is we can look at anybody whose charges have changed. So specifically, silver starts out here as a +1 charge and ends up over here having a charge of 0. If we look up silver on the periodic table, we'll see that silver has an atomic number of 47. That means silver has 47 protons. In a neutral atom of silver, we also have 47 electrons. So that's on our product side when we end up with our neutral silver. Looking at our silver over here that's combined in a compound, we have 47 protons. An electron has been lost to give us that +1 charge, so we actually have 46 electrons. What this actually tells me is that from the left side, the reactant side, to the product side, the silver atom, or the silver ion, gained electrons. So it has 46 on the left side over here, and it has 47 over here. So silver has gained electrons. If we next choose to look at copper, copper has the oxidation state of 0 on the left-hand side, and then on our product side has a +2 charge. Copper has 29 protons, neutral copper has 29 electrons. This is still copper over here, so we still have 29 protons, but because of the +2 charge, we only have 27 electrons. So what actually occurred here, if we look at our silver specifically, when we go from our left side over to our right side, we are gaining an electron, and our copper actually lost electrons. When something loses electrons, it's considered to be oxidized. So copper, specifically neutral copper, lost electrons and was oxidized. And our silver ion, it's in the compound, but it's really acting as an ion there, gained electrons, so it is reduced. Specifically, if we have to define oxidation and reduction, oxidation is a loss of electrons, and reduction is a gaining of electrons. What you'll notice, when electrons are lost, so copper is losing electrons, it starts at 29, goes down to 27, its charge is going from 0 to +2. So what's actually going to happen here is we're going to have an increase in charge. Reduction, if we're looking at silver, Silver starts with a +1 charge and ends up with a neutral charge. So silver's charge is actually decreasing. The reason I'm drawing attention to this is people see oxidation and reduction. They see the word reduction and they're like, why does reduction mean gaining something? The reason for this is we're gaining something negative. So reduction actually means that we're gaining electrons and therefore reducing the charge on this species. It's very easy, obviously, to get this backwards. So we have a little saying that we like to use, which is Leo goes GER. Lose electrons oxidize, gain electrons reduce. So that kind of helps you remember what's going on in terms of gaining or losing electrons. If you don't like Leo goes GER, you know, it's something a little darker, a little more gritty, you can go with oil rig. Oxidation is loss, reduction is gain. Another similar type of reaction that you can look at is another single replacement reaction here, where we have copper nitrate copper nitrate and zinc doing a single replacement reaction. Our copper starts as +2 and ends at 0. So in this case, copper is getting reduced, and 0 is getting oxidized as it goes from 0 up to +2. So I just want to show you an animation. I'm going to begin this at the beginning. Initially, these copper ions in solution, the solution is actually blue initially. It's a little bit darker blue because of those copper ions. Copper solutions are blue because copper is a transition element. So we initially have this copper nitrate solution that was shown in that reaction. These copper ions, you can see floating into solution. What's happening when they float up to the solid zinc, so this solid piece of zinc over here, which is neutral zinc, what's actually happening here is this exchange of electrons. So what you can actually see that they're animating right here is the zinc is actually giving electrons to the copper. That's going to actually cause the copper to now become neutral copper. So you'll be able to see that happening with that guy right there. That guy will gain those 2 electrons and become neutral copper, which is actually a copper atom, which is what we think of as like a solid copper wire. So I'm going to let this continue to play, hopefully. Okay, or I'll replay it, sorry. So hopefully there we go. So now we're able to see this occurring. Those electrons are being gained by those copper atoms. And now those copper atoms are actually sitting there as solid copper, while these zinc ions actually float away on solution. Interestingly enough, they do change the color of the solution in this animation, since a zinc solution is not colored. A little bit of background. Reactive elements tend to gain or lose electrons. Most reactive elements are the ones found on the left or right edges of the periodic table, but not group 18. Remember, that's our noble gases, so they're pretty non-reactive. In general, remember, non-metals like to gain electrons and metals like to lose electrons. However, metals can be forced to gain electrons by the other metals that are around them. So we actually saw in that animation that copper was being forced to gain electrons by zinc. Elements with higher electronegativities, remember, are likely to gain electrons. So electronegativity does play into this reactivity and who's going to gain or lose. And because of this, they often form anions, or in other words, they can also gain electrons and be reduced. Elements with a low electronegativity are likely to lose electrons and form cations. One of the things we need to be able to do is a little bit of electronic counting. So we're going to do that in this table by looking at, these are some simplified ionic equations. We don't really see what else is going on there, but we can look at our numbers of electrons and actually count them here. So we've got a calcium atom changing to a calcium ion. So I'm going to start by we don't always have to do all of these steps, but if I look at calcium on the periodic table, calcium always has 20 protons, okay? Neutral calcium is going to also have 20 electrons. Calcium with a +2 charge, and you can use your periodic table and your electron configuration to help you sort this out. Calcium with a +2 charge has 18 electrons. So what actually happens as a calcium ion becomes a calcium atom is we have a gaining of electrons. And remember, a gaining of electrons is referring to a reduction. To go from 18 up to 20, we're actually talking about 2, and really this means 2 moles of electrons. So each of those calciums is represented in mole. We wanted to look at iron. So iron has 26 protons. Both of these guys are charged. Iron +3 has lost 3 electrons, so this guy has 23 electrons, whereas iron +2 has 24 electrons. So iron did gain an electron here. It's again a reduction. And this time, we only had 1 mole of electrons involved. So oxidation and reduction don't need to involve a neutral species. Often they do, but that's not always the case. Neutral sodium, so sodium up on the periodic table, it has 11 protons and 11 electrons. If it becomes a sodium +1 ion, it does so by losing an electron and only having 10 electrons. When an electron is lost, we call that oxidation, and this involves 1 mole of electrons. Oxygen, slightly different example because we're dealing with an anion here. So if we have oxygen -2 going to neutral oxygen, oxygen has 8 protons, so neutral oxygen has 8 electrons. Our charged oxygen, remember it's a -2 charge, actually has 10 electrons. So we have a situation here where oxygen starts at a negative charge, goes to a positive by losing 2 electrons. So this is again an oxidation involving 2 moles of electrons. This one's a little bit tricky because we kept the little diatomic 2 in there. If you look up chlorine on the periodic table, it's element number 17. So each of these chlorines has 17 protons. So in this first, and 17 electrons also. Neutral chlorine is going to have 2 times 17, or 34 electrons. When we write this as an ion, we actually move the 2 out front instead of keeping it as a subscript. So each of these individual chlorines over here has gained an electron. So each of these actually has 18 electrons. There's 2 of them. So we're talking about 36 electrons here. So in this case, we have gained 2 electrons to go from 34 up to 36. This is a reduction. And if you look at that charge, we're going from 0 down to 1, so we're seeing that charge go down. And we're talking here about 2 moles of electrons. Some places where oxidation and reduction are used, photosynthesis, as I mentioned before, metabolism, turning glucose into ATP. This is actually how a breathalyzer works. It's actually, oxygen is actually reducing chromium ions. They're different colors. There's a little computer in the breathalyzer that can compare the amount of orange versus green chromium. Metallurgy, batteries, if you ever hear about something being electroplated, sweet chrome rims, all that kind of stuff, these are all operating by oxidation and reduction. These are actually some of the most important reactions really in the world.